All right, I think we are live. We are live. This is wonderful. I want to welcome everyone and thank you for joining us today for what promises to be an enlightening discussion about the intersection of wireless technology and software engineering. I'm Grant McGaw. If you did not know, I'm the CEO of Five Star BDM, and I am happy to be moderating this session with two distinguished leaders in their respective fields. And we're living in an extraordinary time where the fusion of wireless innovation and sophisticated software engineering is revolutionizing businesses and how they operate and the people who live with these technologies. So today we're going to explore this transformation with our exceptional panelists, Darren Millette, a pioneering force in wireless infrastructure advancement, and Ronald Shaw, whose expertise in software engineering and integration has helped countless organizations embrace digital futures. So, over the next hour, we will delve into the latest advancements in wireless technology, examine implementation challenges, and explore how these innovations are enhancing user experiences across various industries from healthcare to smart cities and beyond. So we've saved a lot of time at the end of our session for questions, or during the sessions we've encouraged Q&A. So we want to ensure that we deliver practical insights you can apply in your own organization. So without further delay, let's begin this important conversation about shaping the future of connected technologies. So Darren, I'd like to start with you. And here's the question: what are the most exciting advancements in wireless infrastructure today, and how will they redefine industries like healthcare, smart cities, and mobile communications?
Well, that's a great question, Grant, and thank you for having me be a part of your show. And nice to see you, Roanoke. Look forward to this discussion. Well, when you look at wireless technology, right, you have to really peel it back. A lot of people think wireless; they think 4G or 5G telephone. Um, there's a lot of aspects of wireless that I think we need to break down here as we move into this conversation of the impact it's going to have, I believe, going forward. So, wireless connectivity, as we all know, when we walk into a building, when we walk into a home, we're very quick looking for Wi-Fi, right? So, being able to connect to a network is very important just for personal use, right? So I can get on my email and my phone. As you start looking at a building, as you start looking at a city, today, I would say almost 99% of the things that need to connect don't have anything to connect to. So when you look at a hyper local area, what we're going to need is wireless technology that allows us to connect cameras that can do 4K and 8K type of streaming. We're going to need connectivity that can actually come to actually buildings or city locations to be able to bring the data from where it's being collected back to a central point or a brain. We would call that AI, cloud computing, edge computing. So looking at wireless connectivity, we have to look at it above and beyond just your cell phone or above and beyond 3G and 4G technologies that we can connect to. Those networks are really designed for mobility. They're designed for us to communicate on our phones. They're not really designed to implement the kind of software that Roanoke is already developing and that he will be developing going forward to bring intelligence and to bring smart to buildings and cities and applications. So the physical layer of building this infrastructure, we used to spend $30,000 or $40,000 to be able to transmit 1 gigabit of data a few miles. Now we can transmit 10 gigabit of data in some instances up to 20 miles for $500. So when you start thinking about the innovations that are occurring in wireless, I call it Metcalf meets Marconi. Right now, we have the capability to transmit massive amounts of data, not only to and from distances, but when you walk into a building, Wi-Fi 6, Wi-Fi 7, and Wi-Fi 8 technologies bring an abundance of technology and connectivity, but also the ability to give somebody prioritization or to give a camera prioritization. So I wanted to start the discussion really talking about the physical layer of wireless and the differentiation that we need to understand for what's coming for new 21st century digital infrastructure. Great question.
No, I appreciate you laying the foundation because we all know that the physical layer is the cloud. It's kind of an oxymoron, but that is the truth. But is it up to snuff? Is it up to speed? Can it handle the inherent load that we're looking to put upon it? And then as we look at it from a software layer, now I'm going to direct this next question over to Roanoke Shaw because everyone knows, AI is just bananas right now, but it is a creature that's been released into the wild that we really don't know exactly how it's going to behave. We have some assumptions, and that's about it. So here's the question for you, Rono. How are advanced software frameworks enabling companies to fully leverage these new wireless infrastructures? And what role does integration play in unlocking their true potential?
I think
Ro-
Roanoke, maybe
did
he
Ronald freeze
froze.
on us? Yeah, it looked like he froze for a minute.
Well,
Unfortunately, I know.
while he comes back, Grant, what I will say about
Yeah.
wireless is, it's actually faster than fiber. It can be designed to be more resilient than fiber, meaning if you have fiber coming into your building, that's just one route of traffic that can be cut, and you don't know where that fiber goes once it leaves your building. So it's actually a that can be a problem even if you have fiber. Now 75% of buildings in America do not have fiber optics, and if you think
Mm.
about cities that want to implement smart technology in the software that Roanoke is developing, you're going to need a more resilient architecture. So wireless is actually better than fiber. That's the narrative that I continue to fight against. It looks like we got Roanoke back.
Yeah, yeah, I'm sorry. I had to switch the network because of the connection issues. I think I was able to get your question, Grant, about the advancement in the software frameworks that reshaping the wireless world. So definitely, let me just highlight some of the key parameters. How advanced some software frameworks are very, very essential. Especially into the it really helps more on the seamless integration side or optimization or the scalability of the application. So if we really look at the okay, are you guys still or am losing it?
No, you're fine now.
Yeah, you're good.
Yeah. So first very important part is the enhanced connectivity, which I'm already facing a problem right now. The enhanced connectivity and the performance, so the frameworks that really the next generation wireless technologies like 5G. You know, you're able to capitalize very ultra low latency or high bandwidth for faster connection speeds. So that's very, very important on the software advanced framework, and especially in the seamless handoff between the networks are very, very important. So because of the advanced software frameworks that allows devices to move between different types of wireless networks very easily, between 5G or Wi-Fi 6 or Wi-Fi 7. Think of you're in a big resort. When you go to the big resort, when you go from one point to another point, you don't have to switch the networks. This is the seamless integration or seamless handoff is very, very important, and that's where the software view to help that out. Now, in terms of the the edge communication, advanced software frameworks, now this supports the edge computing. So the processing part closer to where data is generated. And it's very, very important, especially in the IoT world, where the processing power is near to the where the data we can
Well, I think we lost him.
I think we're making a great point as to
message on my
my
screen.
business
I'm not
model,
sure if you're
Grant.
still able to hear me. Grant,
Now we see it. We see it.
you
Yeah,
there?
you've got some connectivity. I know you're in India right now, and and Darren just made a point. Like this is, what we're experiencing now with load on across a worldwide network and what that really looks like. And you made some points between wireless and fiber and how that's going to look as we move forward. But give us a little bit more insight while we
Yeah,
wait for
Yeah, I mean,
Ronald.
it's a great example. Now, I know Ronix in India, and they have great internet, by the way. They got great broadband in India, as a matter of fact. And the US, I mean, we have the same problems here. So, you imagine we're just doing a video conference call right now. Imagine if you're running a real application, an AI application that's critical, meaning, it's important. And then you have this type of situation. The current network infrastructure in the United States, there is no service level agreement. Even if you have fiber going to your building, you're not going to get a real service level agreement from the incumbents because they know their infrastructure is vulnerable. It's also very old. And these companies don't have the capital to invest in the demand that is already here today just for basic connectivity. So when you think about the digital divide, Grant, now we're going to move towards a digital plus an AI divide. I want to run AI in a building, or I want to run AI in my city to detect guns, cameras that can detect guns, or traffic signals that will move based on computer vision. You need a network infrastructure that is reliable, resilient, has redundancies, not only in connectivity, having multiple routes, but also has a backup power source in the infrastructure so that if the grid goes down, the new power source, the backup power, would be able to kick on in multiple geographies, in multiple locations, a hurricane, an earthquake, a fire. We know in California, we know in Hawaii that the cell phones didn't work and the alert systems didn't work because the networks went down. And this is where we're going as we talk about the tie-in of connectivity and AI software and what Roanoke and his team are building, those types of applications. I think we're in the very early stages, Grant. I mean, if you looked at this as a marathon, I don't even know that we're starting to warm up in the parking lot yet because there's so much work to be done to build the infrastructure. And we all know the hype around NVIDIA and building these hyperscale data centers and building this infrastructure in West Texas. That's a big piece of it, right? We know that we need those gigantic brains, but the idea that we're going to be able to build gigantic brains all over the world, it's just not feasible, right? There's not enough power. If I wanted to have, if I need new power here in one of my data centers in Miami, from what I understand, the wait might be 5 years just to bring additional new power to a data center here in Miami.
Mhm.
So, the architecture of what we have to build at the physical layer is emerging. And there's ways that we're figuring out how to build these networks at 1/100th the time and 1/100th the price of traditional 20th century fiber optics, which put AT&T in debt of 180 billion now. Verizon has a debt of 140 billion dollars.
Wow.
These companies don't have the capital to build the infrastructure in that way. And then looking at the application layer of the stuff that Roanoke is starting to build and others, the ability to, have thermostats in buildings that can turn on and off when there's nobody there, have sensors and that can detect floods. There's buildings here in Miami that have flooding that cost $400,000 or $500,000 an occurrence, and they have two or three of these over a 50-story building. That's a couple $1,000,000. For 20,000 or 30,000 in infrastructure and software, we can solve that problem. But it's going to require building this new infrastructure. It's going to require new software that can scale, that can manage this data and do something with it. And that's the exciting part of where we're going. The impact this is going to make on buildings and cities, healthcare. It's just super exciting.
I'm excited. Now, Ronald, you're back.
Yes, yes.
And,
I think I'm probably hopefully in much better network now. I
sounds
just
good.
switched to a whole different new network. Yeah. So I know I left in between the answering that question, and if you want, I can probably move on to
Well, I
that.
think no. I think it's important for us to really understand because Darren has laid out where the infrastructure is today, and there's some of the challenges that are there. But having smart networks, detection networks, things that are happening, and those handoffs between networks, and you were kind of alluding to that. Can you just take us through that again?
Yes, 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 yes. So we were discussing more about this advancement in the software development world, which is really helping the wireless technology in different ways. So we were discussing more about the edge computing, where the advanced framework really support the edge computing, and the processing power is actually distributed where the data is generated. It's very, very important, especially in the IoT world, where we are able to minimize the latency as well. Now, another important part is the real-time processing. Because of the edge computing, we are able to get the real-time analytics, and that really helps to make the decision much faster. So, and it really allows the faster data transmission between the devices because of that. Now, if we talk about the scalability and flexibility, advanced frameworks really often embrace microservice architecture, and that enables company to build very scalable and flexible application because of the microservice architecture. And a lot of the companies like us, we use containerized environment like Docker or Kubernetes, and because of that, our applications that can be scaled much faster. Now, security and compliance is another bigger aspect here as well. So these modern software frameworks where we are building all these applications, they actually come with a lot of built-in encryption as such, and it is kind of designed to protect the data in the transit over the wireless networks. Because remember, we work in the healthcare world, or there are different compliance like HIPAA compliance or GDPR compliance. We have to meet all those compliance while we build these solutions, because it's not only building the solutions. Most important is where the data is flowing through is something that we have to be very, very careful. And we have something called automated compliance. That's what we try to implement now. So the all these advanced frameworks, they really provide the automated compliance checks, which is very crucial when more data is transmitted over the open or shared wireless networks. So compliance checks is very, very essential. And another part is the interoperability and the integration. So these advanced frameworks, they really offer robust APIs and middleware. Because of that, we are able to connect different devices or platforms or different services within the wireless ecosystem as well. Now, as Darren mentioned, a lot of the companies are struggling because of their legacy systems. They do not have even enough budget to even to upgrade that to the latest technology and trends that are happening. So now you still have to comply your interoperability between the wireless network and the legacy system, which is a very, very big challenge right now. And that's where these advanced software frameworks are really able to help. Really, they try to match the communication standards. Multiple protocols are being used, and we know that, we use MQTT or COAP for IoT or REST APIs for web services. So we use all these different protocols, and that's where we are able to manage that because of the frameworks that we are using. And the most essential and important part I would like to highlight is the AI and machine learning capabilities. So integrating the AI and machine learning algorithms, that's where we are able to analyze the network performance in the real time, and we are able to adjust the connectivity and the bandwidth allocation as well. And that's where the AI and ML has helped a lot. And also AI powered analytics tools. We are able to gain the actionable insights because of using the real AI powered tools, and it has helped the decision making much, much, much better. It makes a lot of improvement as well. And IoT is the world where we use heavily on the wireless networks. So now we have 5G powered factories floors, and we are connecting hundreds and thousands of sensors, and that's where the bigger challenge is, where we see. So and wireless infrastructure, if we really look at this wireless, if you look the telemedicine world or the other worlds, like telemedicine, it really requires very high bandwidth, because in the time of COVID, we had a lot of video calls, and all are being used on wireless network. And now, also at the same time, we are designing a lot of solutions for remote patient monitoring, like elderly homes. Now, some of those are in such an area where the connectivity is a bigger issue, and we still have to work on low latency for real time patient monitoring. So there are so many challenges we see, and because of the advanced software frameworks, we are able to overcome that in much better way. So these are the different ways where advanced software framework can really be essential for optimized wireless infrastructure.
Before I switch over to Darren, I got to ask you this, Rona, because this is brand new news that just came out or broke news here in January 2025 on the DeepSeek. DeepSeek is out of China, but it's a software integration that is making compute faster, better, more efficient. I don't know. Can you just give us some words? What do you think about that?
Yeah, so this is a buzzword for last 1 week, in reality. And if I'm pretty sure everybody is following the stock market, and we had a great dip in the stock market yesterday. It's only because of one company, DeepSeek. Right now DeepSeek, they came out. I tried the model yesterday as well, and I asked number of different questions to see how well it really resonates with the Chat GPT or Google Gemini answers, and it really produces a similar way. Now, if you remember, several months back, um, US has banned Nvidia to send some of the high-end GPUs to Chinese companies. So China even still developed this open open chat kind of things, like similar to Chat GPT, and they built it under $6 million, which is absolutely. And they didn't even use those high end processors of Nvidia. They used all low end stuff, and they built it below $6 million. And that's where people think that, oh, really, we don't need Nvidia anymore, or how come other companies spend open AI, or whoever spent like billions and millions to build this, and that's where we all see this, that there are possibilities of using. Now, okay, so DeepSeek do not answer number of things. If you ask them who is Chinese president, or you ask something, anything which is related to China,
Mhm.
it would not answer those questions. There
Mhm.
are some restrictions that we see, but apart from that, we see a lot of revolution that it's going to bring. We'll see how it. First thing is, everybody's trying to figure out how did that happen. Like within 6 millions budget range, how did that happen? So we'll see.
Yeah, I got a couple quick
Interesting.
comments to make on that. I think what
Go
we're
ahead.
hearing though
Yeah.
now more recently today or yesterday is that maybe they do have a tremendous amount of GPU that they bought illegally or under the radar. So there's a higher investment really than what is disclosed because they're trying
Yes.
to, who knows, make some noise. But I want to go back to what we started this conversation about, and I'd like to hear Rono, confirm or deny this. That's a centralized software platform, really. Like it's LLM, and Grant, you as well. I'd love to hear your comments as well. There's applications for that, right? I mean, I use ChatGPT, I use Grok, I play around with these, and other people are doing things as well with chatbots and so on. And that's one form of large language. And from what I understand, it's used all the data that's out there already in the world, like all the data that's ever been produced and put on the internet. It's taken it and played with it. Um, we're talking about an entirely different ecosystem that I think is what I consider to be monthly recurring revenue, meaning we're going to put cameras and sensors in buildings that collect data that tell somebody that cars are being stolen in the parking lot. 80% of shootings start in in parking lots of all shootings. So why not have cameras that can collect data and get it to the brain? And it doesn't have to go to the centralized architecture. And to your point about security is, we can design these new wireless networks that actually do not touch the internet. So the data is completely sovereign to the owner of the network or the city or the building owner. So that data is sovereign and it can be routed back and forth between collection point, edge brain, and then actionable, outcome. And that's a whole different ecosystem that we are well in the
Mhm.
early stages. And from what I hear, and I've asked a lot of experts this, that's inference, right? So there's LLM and then there's inference. Inference is really, I think, where the money's going to be at. Inference is going to be where we're going to get tremendous outcomes, but we're going to have to build the new physical layer, and companies like yours, Roanoke, will have to work building this software and making it secure and making it actionable. And I think that's the 21st century.
And very true, very true, Darren. I definitely agree on that. It's very much important that your data can be protected if you do all the processing through edge, and you don't have to send it to the cloud, because you're not really processing anything outside of your premises or your city premises or whatever defined areas are. So you can do all edge computing, and all the decisions making can be done right there within the vicinity of defined area.
Very, very important. This discussion is where we're headed. We've got some questions in the chat talking about legacy infrastructure, how we've got to move the needle forward. How do we implement these new technologies? And this comes to the next question for Darren. And what we really want to get is to the essence of is the biggest challenge in implementing next gen wireless technology, especially when it comes to scalability and AI integration. Can you weigh in on that
Yeah, and
question?
to our previous point, latency is a big deal when it comes to real actionable AI. If you don't need the data quick, you can send gigabits and terabytes of data to the cloud, to the hyperscale cloud, and let it crunch and come back. But real data is going to be really important, right? The ability to a leak is occurring, and we need to notify the building manager that there's a leak so that they can go turn off whatever may be leaking. That's real time. Or someone's pulling a gun in a parking lot, or someone's stealing a Rolls Royce in my parking garage. These are real, actual that require latency. The idea that we're going to have 150 cameras in a building. We're going to build this. We're going to put cameras. We're going to have 1080 or 4K or 8K data. You start doing the math on the amount of data that these cameras are collecting and these sensors are collecting, and you think that you're going to send 3 gigabits or 5 gigabits or 10 gigabits from Miami to West Texas, where the power is cheap, and back, the transport costs will kill the model. The infrastructure, I don't believe, even exists in the last mile of American infrastructure, that you'll have multi-gigabit connectivity at the Fontainebleau Hotel, the Ritz Carlton, the Bentley condominium. The infrastructure just doesn't exist. So building this new infrastructure requires an entirely different type of thinking. And with regards to the technology, I think most buildings and most people, even Ronak can do it now. He can do a trace route. Grant, you can do a trace route and see where your internet goes from A to Z. Where does it actually ping through? What routers? And you'll find that it bounces around. It goes all kinds of different places. And each one of those represent a vulnerability in the 20th century. So building this new infrastructure, every city in America at least has fiber that runs around the city. Many of them have extending hyperscale data centers. So building new infrastructure, the way I see it, it can only be done is it has to be done in a wireless fiber way. We don't have the money, the time, the capital to dig up every street and connect every building. That's been tried. It doesn't work. It will never work. Um, the idea that we're going to connect every street light with fiber so that we can enable intelligent traffic signals. Miami is the eighth most congested city in America because you sit at a traffic light with it's red and there's nobody on the other side. So that and the technology exists to enable all of this. So the one thing, and I know the capital is coming into this space because we just have to look at the amount of capital that was announced in Washington this week that they want to put $500 billion into AI. I believe that number will be 50 to 75% in a new architecture because they may spend $100 billion trying to do the old way of these hyperscale and building data centers where the energy may be cheap. We need that, but we're going to have to shift that capital allocation to building new infrastructure that makes sense and that has a return on investment that's not 10, 20, 30 years in some instances.
Hmm.
Building new
Very,
building new
very important.
power, even in Miami or Austin, building new power is more expensive than building fiber, and building fiber didn't scale. So, trying to upgrade all the power lines going to every building in every street, it's just not technically and financially feasible. So we need new models for sure.
Understood. And we're getting some questions then from the audience in that same area. How we're going to go forward. depending on where we're at, because we have really an explosion in software development. So this question is for Rona, and from your experience, what are the key software engineering principles that we can utilize to overcome some of these hurdles that Darren just talked about, integrating complex wireless systems, AI, IoT, or even mobile applications as we go forward. What can be done at the software level?
Yeah, so this is very important when it comes to the key software engineering, because the software engineering principles are very, very critical to support all these problems in the world. And most important, when we build this kind of solutions, we always go for something called modular architecture, or we use microservices. So when we use this modular architecture, or particularly microservices, we try to break down these components into the independent and reusable modules. So when we do this, we can easily use these modules again. We can redevelop, test, and deploy it individually very, very quickly. There is something called separation of concerns. It's called SOC in our language. So separation of concern involves organizing the code in such a way so system addresses a distinct concern every time. So because we have user interface layer, we have business logic layer, we have a data handling layer, and we organize the code in such a way so it really addresses the distinct concern every single time. Because in the wireless system, data flows between the devices and networks, and each layer needs to handle its specific functions very, very effectively. So that's why separation of concern, which is SOC, is very, very important. Now, when we build these solutions, we also try to keep the resilience and the fault tolerance. We try to build that into this as well. So, wireless system, we always know that sometimes it really operates in very unpredictable environments, like especially in the IoT application world. So if we need to make sure that fault tolerance into the architecture should be built, and in such a way that system can continue functioning or gracefully recover when parts of the system may fail. And we do see the failures. So we really want it to even continue functioning even at the time of the failure. So that's very, very important. And we also do something called asynchronous programming. So that's very essential, because in the event driven architecture and in the ideal wireless systems, the asynchronous programming is very, very important, because system can react to number of different events. Because there were time where, you know back in the time, the solutions were designed in such a way that it's kind of a queuing process. One process has to end before the software will take care of the another process. But now, because of the asynchronous programming, we can handle multiple events at the same time, and that's very, very important. And now, security by design is very, very important. So in the wireless systems, where data is transmitted over the potentially untrusted networks, uh, we actually use AI models to process the sensitive data. And we use these models, and we use the security from ground up when the applications are built. So that's very, very, that's where we see the AI use as well. And the scalability and load balancing is another critical area, because as a system grows, you never know how much data you're transferring, or how much load you're going to take, depending on what cameras is processing what at the time. So we have to have an ability to scale it, even the horizontally or the vertically. Horizontally means, let's say your system is overloaded, you should be able to add more physical capacity, like more machines to it very easily. Or vertically means, you may have to upgrade your system very quickly, so you should be able to update your system. So it's called vertically in our language as well. So it's very, very important that you are able to scale your load balance your system at the go. And interoperability and standardized protocols are important, because in wireless systems, particularly in IoT and AI, there are different devices, different applications, and they all need to communicate each other with using different technologies. So interoperability
Mhm.
through standard protocols is also very, very important. So we also use continuous integration and continuous deployment, which is CI/CD, because in AI and IoT, we develop new features every single day, and there are bug fixes and there is optimization going on. So we do a lot of releases every single day. So CI/CD, which is continuous integration, continuous deployment, is very important because that creates a pipeline and we can automate all these processes very seamless, so we can build, we can test, we can deploy everything in the same go. So CI/CD is very, very essential. And now real-time monitoring has helped a lot, because we are able to gain a lot of real-time analytics, and constant monitoring are very important to ensure that if the system is functioning optimally the way we want. We also use something called TDD, which is test driven development and automated testing. So TDD and automated testings are very, very essential in our world, because that's where we ensure the code which is written is top level quality and it's a reliable code. So it's a lot of our automated tests would tell right away that if our developer has done the right job or not as well. And we implement the unit testing, integration test, end-to-end test, and also in the IoT world, what we do, we create the simulation environment as well. So, even if you have a 5G factory floor with thousands of IoT sensors, we create the real time simulation similar to that to see how it's going to behave in the real world. And then we deploy it into the real world. So, these are the different key software engineering principles which are helping a lot to overcome number of hurdles in the wireless world.
I like that. Because you got to be more efficient with the load that you have, right? Now I'm going to pull this one over to Darren, and this comes directly from the audience from Chiadi, if you've seen that
Yep.
there. But he says specifically, I've often thought that we have been diving headfirst into these data center infrastructures and not thinking long term about maintenance, so as to not waste time and money when we start to see the eventual environmental effects on these centers. What are your thoughts on the progress of renewable energy and its place in wireless connectivity and AI, especially now with DeepSeek creating their system at a lower cost? Can you weigh in on
Yeah, it's a
that?
great question, and thank you for that one, Chiadi. So I believe this is very timely. In fact, I started thinking about this a couple of years ago. This very question that building hyperscale data centers, tremendous amount of capital. It's centralized in its structure, requires tremendous amount of power, which is difficult to get and maintain. And then you think about the investment. I'm no expert in data center finance, but from what I understand, some of these data centers may have a 100-year payback at their current structure of the way they've been funded. Sort of the build it and they will come mentality. I think that's very risky. In fact, if I'm advising, or if I'm putting my own capital, in fact, I am putting my own capital, I'm putting my money where my mouth is into this model where I believe we decentralize the compute and storage, so it doesn't cost as much. And instead of having a giant data center every 20 or 30 square miles, we have 20 or 30 mini data centers per square mile. And this allows us to have more efficiency and the ability to decentralize. And there's a lot of benefits in decentralization. The biggest, in my opinion, is the cost, and not only the maintenance, but the sustainability of that asset. I believe that asset can pay back faster. Plus, we can use solar and wind to power the mini data centers because we don't need as much power at the centralized. You can't build enough solar and battery to power a massive, megawatt data center. But if you have smaller little mini edge computes, you can use solar and battery to supplement whatever power may be there from the grid. And now you start having a model that I think is more sustainable, more resilient, more reliable. So that's a great question. And like I said, if I had all the money in the world, like evidently these guys do with Trump earlier last week, instead of putting $500 billion into all centralized, I'd be placing my chips a little bit more in different ideas. And hopefully, hopefully that will happen. I do believe it. It isn't hope. It has to happen. I don't think we can do this in a decentralized approach. And to
And
Roanoke's point about medicine as an example, you think about a medical office where you come in, you have an X-ray or you get an MRI. That data ought to be immediately transmitted into a private cloud that the patient and the doctor and the health group know is secure and reliable and immediately actionable based on what medicines I'm taking, based on my history of my health. Doctors have to do this today almost manually, right? We come into a doctor's office, we fill out the forms. I mean, we have a long way to go, and it is software, right? I mean, we got to build the software that can collect this data and keep it secure and be able to make it actionable based on whatever drug I'm taking. All of a sudden, I've got a lump in my throat. You know, AI can really help the doctor and the patient, and I think that's a lot of people are scared about AI as an application in medicine, as an example. I think it's the farthest thing from the truth. I think it will bring in efficiencies and save lives, and then that data can go to the large language model, so that maybe they can start thinking about how to, create new medicine like they were talking about. So, like I said, I think we have like I said, we're maybe in the first mile of a marathon here, but it's an exciting place to be. So, great question, Chatty. Thank you.
no, great question, and all of you're right. We are on the precipice of a great technological evolution. And our technology has been around maybe 50, 60 years to a certain degree. Internet's been around what, almost 25 years now, and it's very good at supporting an infrastructure. Through, unfortunately, the COVID experience, we begin to see that we can manage a worldwide load that we never could before. Talking about high end bandwidth, with video and things like that. The end user experience is what we're talking about, right? LLM is just one aspect of AI, right? We get into automation, get into computer vision, things that the Ronak is kind of alluding to. These are important things when it comes to the end user experience. So my question to Ronak is about, how do you ensure that advanced software platforms will seamlessly integrate with new wireless technology to offer the best possible user experience across all these different verticals?
Yeah, so that's a good question, Grant. And to deliver the best possible user experience across different verticals, the several strategies are actually required. So first of all, when we build any kind of software, user experience is very, very big thing that we do a lot of research in such. So there are different aspects. So let's say first is cross-platform compatibility. So platform that we are designing that might need to interact with different operating systems, different devices. It has to go through different networks, like there are different networks that it has to operate under. So ensuring that the software that we are designing is very, very compatible across different platforms, devices, and wireless network is our first criteria when we design this. And we build software which is cross platform development framework. So we use specially like React Native or Flutter. So we use these platforms when we build this, so which is compatible across different iOS, Android, or computers, and different networks would also manage and handle it. Now, another part is user-centered design and user experience research. It's called UCD and UX research. So we do a lot of research when we design this solution. So a very deep understanding of the target user is very much required, because we work with healthcare industry, we work with automotive or retail. Like healthcare, the when we are dealing with healthcare industry, the patients, majority of the time we see a lot of elderly patients using the devices. So we have to make sure then we are designing a solution which is very much compatible with that age criteria. And like in the automotive or retail world, it's kind of different level of users are using the e-commerce platform. So we have to design the software where the user experience really aligns with the end users expectation. And we also have to make sure the wireless connectivity which really improves the experience rather than complicates it. So we have to build a software which really complies with the wireless connectivity as well. So we have a special UX research team in each vertical who try to understand the pain points and of the end users, and then they also work on the desired outcome, and then they design the whole solution. Now when we are designing the solution, we always consider the edge computing parameter for real time processing, so especially in the IoT or healthcare world, real time data processing is often needed, because wireless technology sometimes may introduce latency issues, so we have to be very careful using that along with the edge computing, because edge computing really allows processing data closer to device. It reduces the latency, and eventually we are able to improve the responsiveness. That's the end goal here. And network optimization and load balancing is very crucial. So optimizing the network usage, balancing the load effectively is very very important. So we have to make sure that we built in our solution so users have a very smooth lag free experience during the peak usage time, because there are times where the load is so high, and that's where your system really need to manage and give the responsive response in time to the patients or whatever you are treating. And we use heavily AI right now, so we are trying to do the AI driven personalization. So AI can really adapt the user experience based on the individual users preferences, so AI models are learning every user that is coming into the system, and they are trying to understand their preferences, their behaviors. AI also is trying to understand their network conditions, like what network they are operating on, and based on that, AI actually performs and fixes and optimizes the solution right on the go, and gives a much better experience to the end users, especially if you look at the entertainment world. The models understand that now you're trying to use a heavy video or Netflix or something, and it has to give you that level of experience. So that's where the AI driven personalizations are going on in every software that we are building right now. And especially security and privacy standards are very very important, because when we are using this wireless technology, there could be a lot of vulnerabilities that can happen over the wireless network. So when we are building this software, especially, every day on the phone we are using our bank applications, we are doing financial transactions, transferring money or sending someone payment through Zelle, or you're even accessing your healthcare records on your phone. So we have to do a lot of strong security measures by end-to-end encryption, secure authentications, two-factor authentications, data privacy protocols has to be used as per the guidelines of HIPAA or GDPR. So there are so many security and privacy standards that we have to follow, and we also adopt a zero trust security models, which is very much implemented now into number of softwares that we're designing. So that's very important. And now the real time monitoring is also helping us a lot. Because of that, when we do real time monitoring of the software performance, we are able to gather the insights of how the software or the wireless technologies are performing, and we are able to identify the bottlenecks and improve the user experience right on the go. So these are the different ways where we are trying to give the best experience to the users in terms of the user experience, user research, and the overall optimizing the networks.
I got to get Darren's input on that because the ultimately the end user experience is the goal. The improvement of the delivery of excellence. To Roanoke's point, we're so used to having a video first experience, which is is a heavy load, on the bandwidth, and then when you put on top of that another intelligence like AI on top of that, it just doubled down, on all the things that we need to be doing. So that is the question for you. I mean, do you see, with these private 5G networks, these enterprise settings, how is this going to tax an IT department? And how are you and what you're doing at your company going to help with these new integration
Yeah,
challenges?
unfortunately, just like during this call and many calls that we've all had in the past, you see people experience a network outage or something happens, right? This is commonplace, and and we're talking about a pretty low latency and low bandwidth application, on these video calls, maybe 4 megabits, something along those lines. Going forward, we can't have that. And Jim Carlini he's made some very good points on the chat group here on our call about buildings. Each building has a finite amount of bandwidth, and each building has a finite amount of power. So, the only way this changes is that some company comes in and brings more bandwidth, whether that's fiber optics, whether that's wireless fiber, whether that's 5G fixed wireless access from a modem, or whether it's Starlink. I mean, Starlink is making an impact as an alternate connectivity to the cloud capability. But all of these are realities. And I've always thought that connectivity is the foundation first. If you don't have a good foundation in your doctor's office, in your building, in your place of work, in your home, well, you're at a disadvantage. You're not going to be able to use the great software and the great AI that's coming because you don't have the capability to connect back to it in a meaningful way. Hospitals typically have pretty good bandwidth because they were smart. They had the capital where they could have two routes of internet at minimum coming one from one side of the building, maybe from another, maybe from two different providers, two different networks. Obviously, that creates the resilience that you need to be what I consider a smart building. Jim talks about, Carlini in our chat group talks about the value of buildings in America. They've plummeted. Some of them they've lost 90 to 95% of their value. In fact, some buildings in America are worth dirt value because there's nobody there and nobody's coming to that building. As we move forward, the value of a building to me starts with how smart is that building? Does it have multiple paths of internet coming in? Is it resilient and redundant? Does it have backup power to at least enable some smart applications? Does it have wireless connectivity within the building so that people can connect freely? You come into Miami, into many buildings, if you go above the 8th floor, your cell phone doesn't work because cell towers are pointed down. And if you're in floor 10 or 20 or 30 or 40, your phone doesn't work because you have no cell coverage. So, these are, and by the way, these are things that my company have been pioneering trying to solve. And we are working to scale that now. So we've figured out, I believe, the model to make buildings more valuable, to bring wireless connectivity within the building so that we can enable sensors and cameras that can do smart software applications that are required to lower the operational cost of a building, to make the building more safe, because that's what tenants are going to be looking for going forward. If your building doesn't have that foundational layer of intelligence and connectivity, I don't believe you're going to get any tenants. Therefore, the value of your building may be going down to zero. So, in the past, when you had 100% occupancy everywhere, you could get away with being a dumb building. I think as we go forward in 2025, especially with AI now coming, whether the AI is going to make the building more smart or there's tenants that need that bandwidth to be able to transmit the data that they're building some AI software application so they can get it to the test cloud where they got the big H100 and 200 NVIDIAs and then back. You're going to have this type of architecture. So I think the layer starts with connectivity, and then once we figure out how to scale that, more applications are going to scale and more applications are going to make more money. So, Roanoke, his customers and his clients, they don't want to be able to sell to one building per square mile in America. They want to be able to sell to 100 buildings per square mile in America. And that's the only way that, and we're going to have to figure out a better way to build this infrastructure in a more efficient way.
I agree with you. The economies of scale and the need of both of your your technical expertise in what you're doing, whether it's at the infrastructure layer and definitely at the software engineering layer, because it's all changing. We have such a great adoption of the technology. You brought up an analogy that I really really like, especially when you said about buildings. Think about when you had a Nokia flip phone, you know, I don't know, 15 years ago, right? And why did you stop using that? because the smartphone had more capabilities, more applications. You could do more with it. I don't even know why we call it a cell phone anymore, because it's so much more than that, right? It really isn't a cell phone now. A cell phone, that's just an application in the network. I still remember my Cisco guys telling me, and I was an AT&T guy, telling me, hey, that's just an application on the network. It's not the network itself. And you've seen that change. You mentioned AT&T, you mentioned Verizon. These guys were, operating a one-trick pony for the
Yeah.
most part, just a real-time telecommunications network. That's one thing. Now you've got a real-time data communication network that's on steroids now when you start looking at an intelligence that you're operating in and automation that you're operating in, and then what you can do. So when you have companies like Agile Infoways understanding these networks and how they've morphed, how they've changed, and there's a demand for more intelligence. I can't believe we're seeing with deep sea. And there's going to be many more. That's just one thing. Like, hey, you know what? I can take what we have and make it more efficient, right? I want to ask this question to Ronak. We've got about 2 minutes left. How do you see us being more efficient in utilizing software engineering from a customization standpoint, and not be locked in to some of these big box software solutions that can do one thing but can't do anything else?
Yeah, so software world is changing so rapidly right now, and every day I think I feel like I'm learning every day something new. That's what I would say. I'm still going to school every day. I feel that. So you have to build your software using the latest principles. And what we have seen in the past is anything that we have done in 4 or 5 or 6 years of time, technology is changing, and anything that we have done has to go through an upgradation process. So back in time, something called PHP, I don't even know if people know even that technology now. PHP was so popular. Now it's still there, but on top of that, we are using different frameworks like Laravel or something like that. So a lot of the things, it cannot be something that can sustain for long term. So that's something that when you choose a technology, you or otherwise you build everything on a core technology like Python or Java, which has been there for so many years, and it's going to stay there forever. Like all of the AI models that we are developing, we are using somewhere Python and all those things. So when you're choosing the technology, be very very careful what your platform is, because sometimes the vendors, we are one of the vendor, we are a company, right? Companies would come and tell you that, saying that, hey, this is the best framework, but you have to do your homework, because sometimes company may try to sell you something because they have that people availability or that technological staff available. But you have to be very careful in choosing the technology right framework, which is more sustainable for at least for next 10 or 15 years down the road, because anything that you are building, you're putting a lot of heavy time and effort and money into that technology, and that has to be sustainable for at least next 10 years. And make sure you use a lot of AI and machine learning models, because that's where you're going to have a win-win condition, because core software cannot do what AI models are doing now. And that's where you have to utilize, you have to be very very smart on building any solutions by using the heavy on the AI and machine learning technology.
I love that. Technical debt. I want my audience to really hear that. You might be in more debt than you realize. Final thoughts, Darren.
Look, this is a fantastic discussion. Thank you, Grant, and thank you, Roanoke. I really thought we hit a lot of key points today. Obviously, we're in the early stages, a lot of work to be done, and a lot of great outcomes. I'm not afraid of AI at all. I think everything, just like anything else, things can be used for the good or they can be used for the bad. Obviously, we're all focused on the good. We're going to continue to innovate, continue to make progress, and thank you again for having me on your show, Grant. I enjoyed it.
No, no, no problem. These are the great discussions that we are going to have. We're going to have them going forward because we are all riding this new wave in the digital world, and it's a game changer. I advise everyone to see where all the investments are going, where your technical skill sets are, What are your tool sets that you have? And what more important, what's the mindset that you're going forward? Because you don't want to be where Roanoke just really said, is that you're putting all your eggs in one particular way of doing things, and these things change dramatically. And you just have to understand where you're at and how you can operate. So thank you again. If people want to get in touch with you, Darren, we got 10 seconds. How do I get in touch with you?
Yeah, just through LinkedIn, Darren Milet. You can find me on there, and we can connect and keep going forward. And look forward to spending more time with you two both. Safe travels back to the U.S. next week, Roanoke.
Thank you.
See you
Yeah.
soon, Grant.
No problem. Thank you
You
very much. See you later. See you
see you.
soon,
Bye
Roanoke.
bye.